Hey guys, Mr. Zanakis here, and today we're going to talk about speed and velocity. So what I have here is a Google map that actually shows the directions from Tabernacle, New Jersey all the way down to Orlando, Florida. So let's just suppose that you and your family are going on vacation. So if your family drove the 1,008 miles from Tabernacle all the way down to Orlando, Florida, check out Mickey and say hello down there in Disney, and it took you 19 hours, what was your average speed? Now, if you're looking at the map over here, you're seeing that Google Maps is telling us 14 hours and 59 minutes, almost 15 hours. So what's the difference? Why did it take 19 hours? Well, Google Maps is assuming that you're driving every single minute, and it takes into consideration the traffic time when I actually screenshot this. So in reality, you are stuck in traffic that you're probably crawling along at 5 miles an hour, and other times you're not moving at all. Other times maybe you're going 75 miles an hour and it's wide open on the highway, and everything else in between. You got to also stop to go to the bathroom, get something to eat, but you decide you're going to drive straight through and not stay overnight, so it takes you 19 hours. So what is your average speed? Well, you have to take all that time into consideration when you look at your average speed. So for an average speed standpoint, you're talking about the total distance over the total elapsed time for that trip. So you went 1,008 miles and it took you 19 hours. So just plugging this in, we can find that our average speed for a trip down to Disney from Tabernacle one way would be the 1,008 miles divided by 19 hours, which will give us 53.05 miles per hour. Or if we're using significant figures here, there's only two significant figures in the 19, so you would end up with an answer of 53 miles per hour. Let's take a look now at instantaneous speed versus average speed. Okay, so from an instantaneous speed, you've got a speedometer here, and it looks like we're going about 53 miles an hour, and you figure you're in a 55 mile an hour zone, so you're okay. Now, your speedometer doesn't really know what direction you're going, it just knows how fast your car is going at that very second. So there's still a period of time involved here, but it's a very, very short period of time. If you can imagine, it's less than a second, half of a second, smaller and smaller to this split second of time. How far did we go for that split second if I kept this same speed? Well, that's what your speedometer is reading, is instantaneous speed. But be careful. Now, what you thought you were actually in a 55 mile an hour zone, it turns out you were really in a 40 mile an hour zone. And so all of a sudden, you see some cops behind you. Now just be careful. You might want to say, well, officer, you know, when I was stopped at the traffic light there, I wasn't moving at all and time was elapsing, and you know, when I went through the neighborhood, I was only going 25 miles an hour, and if you add up my total trip and all the time that I've spent, you'd say my average speed was actually 38 miles per hour, so I'm okay in this 40 mile an hour zone. Well, it doesn't really work that way, does it? Your 40 mile an hour speed limit is your instantaneous speed, in which you can see here we were going 53. So understand the difference between instantaneous speed and average speed, which again is going to be that total distance traveled and the total time that's elapsed to get you from point A to point B. Let's talk about velocity now. Okay? Velocity really is how fast you are changing your position with respect to time. It seems like the speed is very similar to this, and that's one of the things that we have to be conscious of. Okay? In everyday vernacular, we often use speed and velocity interchangeably. But here in physics, they are two separate things, and we need to understand what those differences are. From an equation standpoint, we're talking about the average velocity. And instead of total distance, if you remember, distance was a scalar quantity. Here we're talking about a change in position, or delta x, which is really displacement. So it's your change in position or displacement with respect to a change in time. Again, remember that little triangle there is the delta symbol, okay, which just means change in whatever the next variable is. And in this case, change in position over change in time. And every time you see the delta or the change, it's going to be final minus initial. So in this case, we have the final position minus the initial position divided by the final time and the initial time. Now, oftentimes you may get problems where this delta t or change in time is just given to you as the amount of time that elapsed. Sometimes you may have individual times, but just understand that if you tell you the amount of time that went by, they're really talking about the change in time. For a unit standpoint, velocity is measured in meters per second from an SI base unit standpoint. It's meters per second. It has a magnitude and a direction. It is a vector, and it's picking up its direction based on the displacement. What was the change in position? If you remember, displacement is a vector quantity which needs to include direction for your change in position, and this change in position with respect to time is giving us our direction here for velocity, making it a vector as well. And for that reason, it can be both positive and or negative. Remember, that only indicates direction. A negative 5 miles per hour velocity is not less than a positive 5 miles per hour velocity. It just means that you're going in the opposite direction. Speed is not the same as velocity, class. Say this with me. Speed is not the same as velocity. Oftentimes students will think that, oh, well, velocity is just speed with direction, and you'll see here in a second why that's not the case. But without a shadow of a doubt, speed only has magnitude. So speed can only have a magnitude. It does not have a direction, but be careful. You don't just add direction to your speed calculation and call it velocity. Let's take another look at another example here. This is one of the ones that we actually had when we were looking at displacement. All right, so a mountain biker is biked on a winding trail through the woods that was 11 kilometers long. And it took 25 minutes to complete. The end of the trail was actually only 6 kilometers north of the start of the trail as the crow flies, straight line distance. What was the average speed and velocity of the biker in meters per second? Well, when we're talking about average speed here, okay, let's go back to our equation. Average speed is the total distance divided by the elapsed time. So just plugging this in here right from the question, what we have here is 11 kilometers divided by 25 minutes. But we're trying to solve for this in meters per second. Okay, we want both the average speed and the velocity in meters per second. So we need to do unit conversion. And really, because you can convert the units from kilometers to meters outside of this, and then minutes to seconds, do those conversions first, and then plug in your distance and your elapsed time, or you can just set it all up in one equation, which is what I suggest and probably what you're familiar with from chemistry. So we have 1,000 meters in 1 kilometer and 1 minute in 60 seconds. So we're just converting units here. And what happens is that we're left with meters per second. Okay, the kilometers cancel out and so do the minutes, which gives us an average speed of 7.3 repeating, or 7.3 meters per second, taking in a 2 significant digit. So let's look at velocity now. Okay, for our average velocity, again, notice that I'm writing out the equation in variable form. This is something that I will continue to harp on, and it's really important that we don't skip these steps. Early on, the equations seem to be easy, and you can almost put it together in your head, and you want to put it in your calculator and then just jump to the answer. And so please, and then solve. So here we are with the velocity average being a displacement over the change in time, or change in position final minus initial over the change in time. So again, we're going to plug in to 6 kilometers now, not the 11. Our displacement was only 6 kilometers to the north, and the time still is 25 minutes though. That's how long it took us to get to that spot. Again, we're going to add in our unit conversions, and we're going to cancel out our units, and we're left with meters per second, and we have a velocity average of 4 meters per second, which was less than our speed. It wasn't the same number. So are we all done here with our velocity? Is there anything we're missing? Don't forget the direction. Okay? It's very important that you keep that in mind, that a velocity is a vector and it has a magnitude, in this case 4 meters per second, but it's 4 meters per second to the north. It's really important. But again, comparing this to average speed, 7.3 meters per second. So understand that I just can't take the speed and say, oh, the speed was 7.3 meters per second. We went to the north, that's my velocity, 7.3 meters per second to the north. Clearly you can see that because speed is based on distance, which is scalar, and velocity is based on displacement, which is a vector. Those are two different quantities. So let's recap here. Did you learn that the average speed is actually the total distance divided by the elapsed time? And are you able to tell the difference between instantaneous and average speed? That the equation for velocity average is actually displacement over change in time, which again is going to be position final minus position initial, divided by the change in time. And that velocity is a vector with both magnitude and direction. And that speed is a scalar. It is not the same. Speed is not just the magnitude of velocity. Sometimes it may be when you're traveling in a single line in the same direction, that may be the case. But you need to understand that they're not the same. Velocity, which can be positive or negative, again, this is just indicating your direction. It is not indicating a value of magnitude, okay? The negative is just indicating direction. And speed will always be positive. You cannot have a negative speed. You just have speed or you don't have speed. There is no such thing as negative speed. Thank you, and I'll see you again.